Hello students, last class we have studied about the acidic properties of aliphatic carboxylic acid. Now let us discuss the acidic properties of aromatic carboxylic acids. So acidic nature of aromatic carboxylic acid. So the parent aromatic carboxylic acid is benzoic acid. Here two effect arises. One is minus I effect of a phenyl group and another minus M or F effect of COOH group. So due to minus effect of phenyl group, the acidic strength slightly increases. So this group withdraws electrons towards itself. In this it tends to decrease the electron density of oxygen atom, for which the acidic strength increases. In this phenyl group, the benzoic acid is stronger acid as compared to acetic acid. So benzoic acid stronger as compared to acetic acid. So this is stronger acid as compared to acetic acid. But there is also another effect, minus R or minus I effect of COOH group. So what is that? Look here. In the resonating structure of benzoate ion, we can write the resonating structure of benzoate ion. Double bond O here. So this oxygen is more electronegative than this. It withdraws electron from here and this electron comes here. In this way, minus plus like this, and this electron pair again comes here. Negative charge, here positive charge, and again this electron pair comes here. Positive charge, and again this electron pair comes here. Structure 1, 2, 3, 4 and 5. So due to this structure minus I effect, so due to this mesomeric effect or minus F effect, the electron density on oxygen atom increases. In this way destabilize the benzoate ion. As a result, it is weaker acid than that of formic acid. So benzoic acid is weaker than that of formic acid, and due to its minus I effect, it is stronger acid than that of any other simple aliphatic carboxylic acid. So this is your formic acid, this is benzoic acid, and this is acetic acid. So this is the decreasing order of acidic strength of formic acid, benzoic acid and acetic acid. Now let us discuss what are the effect of substituents on this benzoic acids. Effect of substituents on acidic strength of benzoic acid. So remember, two effects are there. One, what are the type of substituents present? It depends on two factors: type of substituent present, type of substituent present in this benzoic acid, and number two, position of substituents. Position of substituents. So what are these factors? First, if there is electron withdrawing substituents presence, so presence of electron withdrawing substituent, presence of electron withdrawing substituents increases the acidic strength, whereas presence of electron releasing substituents or electron donating substituents, presence of electron releasing substituents or electron donating substituents decreases the acidic strength. Okay, remember here. So presence of electron withdrawing substituents with the minus I effect increases the acidic strength, and presence of electron releasing substituents or electron donating substituents decreases the acidic strength of benzoic acid. Okay. Another thing, position. So when we consider about its position, the acid strengthening effect and the acid weakening effect, that is more pronounced at para position than at meta position. Okay. So the acid strengthening effect or acid weakening effect is more pronounced, that means more effective at para position than meta position. At para position, that meta position. And another thing, whether electron withdrawing or electron releasing present, if it is present at ortho position, then that is more acidic than that of benzoic acid. This is called ortho effect. Okay. So whether electron releasing substituents or electron withdrawing substituents, electron releasing substituents or electron withdrawing substituents if present at ortho position then it is more acidic as compared to benzoic acid. This is called ortho effect. Okay. Now let us look some examples of substituted benzoic acid which are present. Substituted benzoic acid which are present at para position. So if you consider about nitrobenzoic acid, para, nitro, you know this is benzoic acid. These two positions are ortho position. These two positions known as meta position. This position is known as para position. 1 with respect to 4. This is known as para position. These two are ortho position. These two are meta position. So if I consider about only the para substituents, this is your para nitrobenzoic acid. This is a stronger acid as compared to chlorobenzoic acid, which is stronger acid as compared to benzoic acid, which is again stronger acid as compared to toluic acid, which is a stronger acid as compared to anisic acid. Anisic acid, also known as para-methoxybenzoic acid, which is a stronger acid as compared to para-hydroxybenzoic acid. So these are the some acidic strength of some para substituted acids with respect to benzoic acid. Now we will discuss what are the effect of substituents of individual substituents with respect to benzoic acid. Now let us compare the acidic character of some substituted benzoic acids with respect to benzoic acid. So here previously we have discussed that is presence of electron releasing substituents decreases the acidic character, whereas presence of electron withdrawing substituents increases the acidic character. Look here, there is presence of methyl group, CH3 group. So this has, due to hyperconjugation, it has plus R effect as well as it has plus I effect. It shows inductive effect plus R effect. So this is strongly electron releasing nature, due to which the acidic character of benzoic acid decreases. But due to ortho effect, this methyl benzoic acid or toluic acid is a stronger acid than compared to other. So toluic acid, this is ortho-toluic acid or orthomethyl benzoic acid. This is a stronger acid as compared to benzoic acid. Then present, this is due to plus R and plus I electron releasing nature. So due to presence of this group decreases the acidic character, and you have also said that if this present at para position, this acidic character decreases more, there is more effect than at meta position. In this way, para-methyl benzoic acid or para-toluic acid is the weakest, then this is your meta, this is your benzoic acid. So due to presence of this methyl group, the acidic strength of substituted meta and para decreases, and para has more effective, this is para decreases more, and due to ortho effect, it has stronger acidic strength. So in this way, this is the order of acidic strength of benzoic acid with respect to, sorry, this is the acidic character of toluic acids with respect to benzoic acids. Next, let us discuss about the acidic character of nitrobenzoic acids. In nitrobenzoic acid, it has both minus R as well as minus I effect. So nitro group is strongly electron withdrawing nature, and it has also minus R or minus M effect because this group gives electron towards this benzene nucleus. In this way, this group increases the acidic strength. So all nitrobenzoic acid are stronger acid as compared to benzoic acid, and due to ortho effect, this is more acidic. Due to ortho effect, it is more acidic as compared to orthoisomer is more acidic. Then if there is presence of electron withdrawing group, it is present at orthometa. So this is due to which this is stronger acid. And electron withdrawing group, if it is present at para position, it increases more as compared to your meta. In this way, para nitrobenzoic acid stronger than meta, and due to presence of this minus and minus R, all are stronger as compared to benzoic acid. So this is the acidic strength of nitrobenzoic acids with respect to benzoic acids. Next come to hydroxybenzoic acids. So hydroxybenzoic acid. You know this OH group has this lone pair of electron for which it can exhibit plus R effect, and due to electronegativity of oxygen, it can show minus I effect. In hydroxybenzoic acid, it has plus R and minus I effect. So minus I effect increases the acidic strength, whereas plus R effect decreases the acidic strength. So this group decrease acidic strength, and this group increase the acidic strength, and they combine these two effect on this hydroxybenzoic acid. So this is ortho effect. This is the stronger acid as compared to this, and at meta position there is only minus I effect. There is no plus R effect. So due to this minus I effect, this is more acidic than that of benzoic acid. And another, this OH group have less minus I effect because acidic minus I inductivity decreases with distance. In this way, it has lower effect of minus I effect, or inductivity is less effective here, but resonance effect is more effective. Plus R effect is more effective. In this way, plus R decreases, hence para-hydroxybenzoic acid is weaker as compared to benzoic acid. But due to presence of minus I effect and no resonance effect, meta is acidic than that of benzoic acid. And due to ortho effect, this is stronger acid. This is the acidic strength of hydroxybenzoic acid. Next come to acidic strength of methoxybenzoic acids. Methoxybenzoic acids, or we can say anisic acids. So due to ortho effect, this is more acidic. It has also plus R and minus I effect. It has also plus R and minus I effect. So plus R effect decreases, whereas minus I effect increases. and it has minus I effect is less as compared to hydroxy benzoic acid. As that of OH group, as that of this OH group, it has less minus I effect than this. Whatever, this orthomethoxy benzoic acid is a stronger acid as compared to benzoic acid, that is due to ortho effect. Next, this OCH3 group has only minus I effect. This group has only minus I effect. There is no plus R effect because at meta position there is no plus R effect. In this way, due to this, it is more acidic than compared to this benzoic acid. And at para position, this is a very less minus I effect and stronger plus R effect. That's why this is less acidic as compared to benzoic acid. And here this ortho effect slightly decreases and it becomes equal to meta-methoxy benzoic acid than that of ortho-methoxy benzoic acid. Next come to acidic strength of chlorobenzoic acid as compared to benzoic acid. So there is no hydrogen bonding in methoxy group to COH group. In this way, this ortho effect slightly decreases than that of hydroxy benzoic acid. Okay, so next come to chlorobenzoic acids. Chlorobenzoic acids have also plus R effect and minus I effect. But here the minus I effect is stronger. This has stronger effect and plus R is also stronger, but this is less effective than this. So minus I effect in this case is stronger. In this, all chlorobenzoic acids are stronger acid as compared to benzoic acid. Due to presence of this minus I effect, it is stronger acid as compared to benzoic acid. And another thing, due to ortho effect, this chlorobenzoic acid is stronger. Whether minus I or plus R, whether what type of groups are present, this is due to ortho effect. This is stronger acid. And between these two effects, so at meta position, only minus I effect is there. There is no R effect. In this way, this is stronger acid. And as minus I effect of chlorine is stronger than that of hydroxy group, than that of methoxy group. So it has, due to the stronger minus I effect, this chloro group is stronger acid as compared to benzoic acid. So in this way, the acidic strength of chlorobenzoic acids, with respect to benzoic acid is in this order. So this is ortho effect, this is the minus I effect stronger, this is minus I and plus R effect, combination of both, and this is the simple benzoic acid. This is the acidic strength of. So this is all about some substituted benzoic acid, the comparison of acidic strength of some substituted benzoic acids with respect to benzoic acid. Now let us discuss what are the chemical reaction which shows the acidic property. Chemical reactions showing acidic property. So anything which liberate hydrogen from, that is known as acid, we can know which gives H plus ion known as acid in this reaction with metals. So carboxylic acid reacts with active metals like sodium, potassium, magnesium, zinc, calcium, etc. to liberate hydrogen gas. In this way, these are known as acid. Look here the example. Plus sodium give rise to plus hydrogen gas. Similarly, if you take acetic acid plus sodium metal, it gives sodium acetate plus hydrogen gas. So here bond breaking takes place between this O and H. So as this is known as this is your acidic property. Bond breaking takes place between this O and H. It shows the acidic property. Next, reaction with sodium carbonate and sodium bicarbonate. Reaction with sodium carbonate and sodium bicarbonate. So carboxylic acid reacts with sodium carbonate and sodium bicarbonate to liberate carbon dioxide gas. And generally this carbon dioxide is liberated from sodium carbonate and sodium bicarbonate, not from the acid. Look at the reaction. Plus. So here this replaceable hydrogen, it gives rise to plus carbon dioxide plus H2O. So carbon dioxide gas is produced or evolved. So this is the test for carboxylic acid from other functional group. This test is used for the identification of carboxylic group. Identification of carboxylic. This reaction is very important for practical. This is identification of carboxyl group. Generally, this test is used. Okay, look at example. This is acetic acid. Reacts with sodium carbonate to produce sodium acetate plus water plus carbon dioxide gas. Similarly, if you take sodium bicarbonate, it also gives you sodium acetate plus water plus carbon dioxide gas. So these are when carboxylic acid treated with sodium carbonate or sodium bicarbonate, it gives carbon dioxide gas. This is used for the detection of carboxyl group. Generally, other functional group do not exhibit this type of test. Next, reaction with alkalis. So as these are acids, these are weak acids, they react with alkalis to neutralize them to form salt and water. So carboxylic acid reacts with alkalis, carboxylic acids reacts with alkalis, neutralize them to form salt and water. Look at the example. Plus it forms sodium acetate salt and water. This is acetic acid. Next, suppose you take ammonium hydroxide. This is ammonium hydroxide. Acetic acid reacts with ammonium hydroxide to form ammonium acetate and water. So carboxylic acids reacts with alkalis to form salt and water. So these are the reactions which shows the bond cleavage takes place between O and H. And later we will discuss the other chemical properties of carboxylic acids. Okay.